So in this question, you're given a 3 by 3 matrix 1 2 1 2 4 3 4 1 1. You're asked to find the inverse of this matrix using elementary transformations. So we have seen how to find inverse using elementary transformations. We are going to use the pivot element method. So first I write 1 2 1 2 4 3 4 1 1 is equal to 1 0 0 0 1 0 0 0 1 times A. So first I am going to use this element and try to convert the remaining two elements in the first column into zeros. So R2 becomes R2 minus 2R1, R3 becomes R3 minus 4R1. So what happens if you do this transformation? R2 becomes R2 minus 2 times this. So R1 is intact. So what does R2 become? 2 minus 2 is 0. 4 minus 2 times 2 is again equal to 0. 3 minus 2 times 1 is 1. 4 minus 4 times 1 is 0. 1 minus 4 times 2 is 8. 1 minus 8 is minus 7. 1 minus 4 is minus 3 is equal to 1 0 0. First row is intact. What happens to the second row? R2 minus 2 times this. So minus 2, 1, 0. R3 minus 4 times R1. So minus 4, 0 and 1 times A. So in the second step, what is the pivot position? This is the pivot position, right? But in the pivot position, you have a 0. As discussed in the previous question, in any stage, if you have zeros in the pivot positions, you cannot use this and make these two as zeros. So you are stuck here. So now what you do is, you should not write A inverse does not exist for a 3 by 3 matrix. So you first try to make this pivot position into a non-zero number by doing any transformation. So can I do that? Yes. So if I have R2 exchanged with R2 exchanged with R3. So if I exchange R2 and R3, I can bring a non-zero number in the pivot position. So 1 2 1. So whenever you have zeros in the pivot positions, you can try to do this. You should not interchange R1 and R2, because if you interchange R1 and R2, this 0 gets disturbed. So you should not disturb these two zeros. So even if you interchange R2 and R3, these two zeros will not be disturbed. So 1 2 1, 0 minus 7 minus 3, 0 0 1 is equal to, here also we do the same thing, minus 4 0 1 minus 2 1 0 times A. So if you get zeros in the pivot positions, this step will be an extra step which you need to do. Now using this minus 7, you can make the remaining element 0. So this has already been 0. So R1 becomes 7R1 plus 2R2. So R3 is not being changed. R2 is not being changed. So R1 becomes 7R1 plus 2R2. So 7 0, 7 minus 6 is 1. So minus 4 0 1 minus 2 1 0. So what does R1 become? 7 times R1 plus 2 times R2. So 7 minus 8 is minus 1. 0 plus 0 is 0. 0 plus 2 is 2. So these two have become zeros. Again, now you have a non-zero pivot position. So using this, you can make the remaining two elements as zeros. So what is the transformation? So using R3. So R1 becomes R1 minus R3. R1 minus R3 becomes 0. And R2 becomes R2 plus 3R3. So minus 3 plus 3 will become 0. So what happens? After this transformation, R3 will remain same. So R1 is becoming R1 minus R3, 7, 0, 0. R2 is becoming R2 minus 3R3, 0 minus 7, 0. Is equal to, here also, minus 2, 1, 0 is same. Minus 2, 1, 0 is same. So what happens to row 1? Row 1 minus row 3. 1 minus 1, 2. Row 2 plus 3 times row 3. So row 2 plus 3 times row 3. Minus 4 minus 6 is minus 10. 0 plus 3 is 3. 1 times A. So now what you need to do is, you need to make these two as ones. So R1 becomes R1 by 7. R2 becomes R2 by minus 7. So the first row, the first matrix becomes an identity matrix is equal to, so first row by 7, that is 1 by 7 minus 1 by 7, 2 by 7, and second row with minus 7, that is 10 by 7 minus 3 by 7, 1 by 7, and minus 2, 1, 0 times A. So this is nothing but inverse of this matrix. So what is the important thing that you have understood in this question? So just because a pivot position becomes 0, that does not mean inverse does not exist. So you can try to interchange the rows and try to make the pivot position as a non-zero number and try to proceed further. So if a non-zero pivot is not possible by interchanging the rows without disturbing the zeros that you have already got, then that means that inverse does not exist.